Today we're going to look at common logarithms. Our goal by the end of this is to be able to use our calculators to find the value for logarithms, give calculation-ready solutions for equations, and to change the base of a logarithm so that we can find the value using our calculators. So, as I've said previously, on our calculators we have a button that says log. It looks like this. We've got a button, has the word log in it. That's log base 10. It's always log base 10 is our most common logarithm. Everything we're going to do from now on, we're going to try and get things into log base 10. When we do that, all we have to do is plug this into our calculator. So, either you'll type, depending on your calculator, log 3.8 and hit enter, or on some calculators you may have to hit 3.8 and then hit log. One of those two ways should work, and when you do that, you get an answer of 0.579, and it says 783597, but we usually round to 4 decimal places, so 78 would round up to 8. And that is the log of 3.8. Common logarithms means log base 10, so 10 to the 0.5798 gives us 3.8 as an answer. Now, if we want to work backwards and figure out what number we're working with, we're going to have to turn this into an exponential form. When we do that, we have 10 to the 2.4825 power equals y. Now, don't fret. If you have a scientific calculator with a log button, you have a scientific calculator that can do this as well. It's usually either second log or second is sometimes known as shift, depending on the calculator. So shift and log. Because above log you've got something that says 10 to the x power. Well, that's how we can do this. So when you hit that, you get 303. You get y equals 303.7386, so on and so forth. It says to 3 significant digits, so I'm going to look at the 3 and the 7. I'm going to round the 3 up to 4. Y is about 304. And that becomes my answer since I said round to 3 significant digits. If I ask for more digits, you give me more digits. If I ask for less digits, you give me less digits. It's the way it works. So solving equations. Solving 3 to the x equals 30, give our answers in calculation-ready form. Now before, we would try and rewrite 30 in terms of 3 to the something power. It doesn't quite work here. 30 is 3 times 10. I can't raise 10. I can't do 10 into 3 to the something power. It just doesn't work. So what I'm going to do is I'm going to take the logarithm of both sides. The common logarithm. I'm going to use log base 10. So log of 3x equals the log of 30. Because what I do to one side I have to do to the other, and if I'm taking the log of one side, I want to take the log of the other side. If I do that, I can now use my laws of logarithms and say x times the log of 3 equals the log of 30. And I'm trying to solve for x. So x equals, let's divide the log of 3 by both sides. Log 30 over log of 3. This is in calculation-ready form. If I asked you to calculate it out, you do figure out what log 30 is, figure out what log 3 is, and divide them. Now, not all our logarithms are in base 10. You've seen that most of our logarithms aren't in base 10 because we haven't really done much with log base 10 until today. What we can do is change any logarithm into log base 10. Makes our life so much easier. So if I started off with something, say, log base 5 of 4, what this tells me is I'm going to use, my new base is going to be 10. Let's make it a common logarithm. Let's make life easy for ourselves. I take the log of the number I'm trying to find the log of originally, so the 4 goes up here, divide it by the log of the base. So it's the log of 5. And if I simplify log 4 by log 4 divided by log 5, I'll get my answer to log base 5 of 4. It's a magically wonderful formula. It will make our lives so much easier. And here's how it can make our lives easier. Prior to this, we would try and do 4 to the x power equals 7 and rewrite it into the same base. Well, 7 isn't a power of 4 or a power of 2. 7 is prime. It makes our life more difficult. But what we can do is use the change of base formula. Log base 4 of 7 equals the log of 7 over the log of 4. And that I can figure out. The log of 7 is 0.8451. The log of 4 is 0.6021. And if I divide the log of 7 by the log of 4, I get an answer of 1.4037. Or 1.0404. Because usually we'll go to 4 significant figures. And that's it. That's all it is. So our goal is to really get things into log base 10 so we can just figure it out on our calculators. If you don't have a calculator, we have to go back old style to the way parents and grandparents used to do it, and you'll probably get a table of values, and your teacher will probably show you how to use the table of values.